Have you ever looked up at the stars and wondered, are we alone in the universe? Well, I'm searching for the answer to this big question by looking in the bottom of a bubbling hot spring pool, and I'm going to show you why that's not as far-fetched as it sounds. The first step to figuring out the probability of life on other planets is to understand how hard it is for life to begin in general. And the only example of life that we can study is right here on Earth. The origin of life on Earth would have required trillions of different chemical reactions coming together in just the right way for that first cell to form. This would have only been possible in an incredibly complex natural environment like a hot spring that could provide all of the different chemical conditions needed for these reactions to work. The problem is that when the majority of scientists try and reproduce these reactions to understand how life forms, they don't consider that vital natural complexity. Instead, they recreate their experiments in the lab using artificial glass test tubes removed from the natural world, often to limited results. My PhD aims to change this by conducting experiments in real hot springs in nature's laboratory, harnessing the natural complexity to power my reactions. My collaborators and I explore hot springs from all over the world, analysing their mineral and water compositions. We find that hot spring fields can have countless pools, with each pool being chemically unique. Because all these pools are constantly splashing and mixing with one another, they can create a nearly infinite number of potential chemical combinations. But are these hot spring systems complex enough to drive the chemical reactions needed for life to form? Well, we test this by adding simple organic molecules into active hot spring pools. We are finding that after a short while, these small molecules can link up to form long chains, similar to DNA, that can be encapsulated inside other molecules to form structures that start to look a lot like cells. From this, we can fine-tune those experiments by adding in water from different hot springs or sprinkling in mineral grains to get a glimpse at what may be the crucial ingredients needed to promote these potentially life-forming reactions. But what does that have to do with that big question? Are we alone in the universe? Well, at the moment, there are over 100 billion planets in our galaxy alone. Without knowing the crucial environmental ingredients needed for life to form, we have no idea of knowing on which planet to start our search. So it's only by harnessing the natural complexity of nature's laboratory that my PhD may be able to provide insight into how life formed on Earth, getting us one step closer to knowing if we're alone in the universe.